So question number 9 is on differentiation but maximum minimum and testing you on stationary value. So without further ado, let's try question number 9 over here. So question number 9 says that the diagram shows the glass test tube, the one that you see in your science practical exam, of radius RCM. Okay, so radius RCM and height h plus RCM with a hemisphere over here of radius RCM has the base. Okay, so the surface area of the test tube is given by 12 pi. So we need to show that h equals to 6 minus r squared over r. So for question 9 part I, okay, we know that the surface area of a semicircle over here is actually 2 pi r squared, and the surface area of the cylinder over here, okay, is actually the circumference of this circle, 2 pi r times the height of the cylinder. So please take note that the height of the cylinder is actually h, because this is r. So here is r. So then here, which is the height of the cylinder, must be h plus r minus the r. So this gives us h. So it's 2 pi r h. Okay? And we know that based on the question, the surface area of the test tube is 12 pi. So this is equals to 12 pi. And then 6 will be equals to RH plus R squared. Okay, so what we did over here is we divide everything by 2 pi. Okay, so we divide this by 2 pi, we get RH. We divide this by 2 pi, we get R squared. And we divide this by 2 pi, we get 6. Okay, so let's bring R squared over. So we get RH equals to 6 minus r squared, and dividing the r over, making h the subject, we get 6 minus r squared over r. And we are done with 9 part 1. So for 9 part 2, okay, we are required to show that the volume VCM cube of the test tube is V equals to 6 pi r minus 1 over 3 pi r cube. Okay, so first we find the volume. So the volume is actually equals to, so the volume of the cylinder this time will be the area of the circle here multiplied by the height. Okay, so that will be the volume of the cylinder here, which is pi r squared, which is the area of the circle, the base area of the cylinder, multiplied by its height. Okay, and for the area of a semicircle over here, okay, sorry, for the area of a hemisphere. Okay, sorry, so earlier, this is the area of a hemisphere. Okay, so sorry about that. So for the volume of the hemisphere over here with radius r, okay, that will be 2 over 3 pi r cube. Okay, so this will be the volume of the hemisphere with radius r, and this is actually V equals to pi r squared. What is h? Because take note that here the V is expressed in terms of r. Okay, so that's why the part I, there's a reason why the question tells us to make h the subject, because now we can substitute this h with 6 minus r squared over r over here, so that we can express the volume here in terms of just r only. Okay, so plus 2 over 3 pi r cubed. So this is V equals to, cancel, 6 pi r minus pi r cubed plus 2 over 3 pi r cubed. So this gives us V equals to 6 pi r minus 1 over 3 pi r cubed. And yep, we have shown that V equals to 6 pi r minus 1 over 3 pi r cubed. Okay, so moving on to part 3. So calculate the stationary value of V and determine if the volume is a maximum or A minimum. So when we want to find the stationary value of V, right, the first thing is we have to find dV dr. Okay, so dV dr is actually equals to 6 pi minus pi r squared, right? So for stationary value of V, dV dr is equals to 0. So 6 pi minus pi r squared equals to 0, which means that we have pi r squared equals to 6 pi. So this cancel gives us r equals to square root 6 or minus square root 6. But the length, which is the radius, cannot be negative, so this is rejected. Okay? So we have r equals to square root 6. So now we know the value of r. We can substitute this r back into the equation of the volume. The volume equation earlier, which is V equals to 6 pi r minus 1 over 3 pi r cubed. So what we're going to do is we're going to sub r equals to square root 6 in V. Okay, to get the stationary value of V, we get that V equals to 6 pi square root 6 minus 1 over 3 pi bracket square root 6 bracket cube. Okay, so let me key in my calculator over here to get the stationary values of V. So this gives us 30.8 cm cube rounded off to 3 significant figures. Okay, so now we got the stationary value of V, right? But we need to know whether this value of V is a maximum or a minimum. So because dV dr is actually quite a simple expression, so I wouldn't suggest that you do the first derivative test. You can try to use the second derivative test and see whether it works. So let's do the second derivative test. D square V over dr square is actually equals to minus 2 pi r. Okay? And sub r equals to square root 6 in d square V over dr square. We get that d square V over dr square equals to minus 2 pi times square root 6, which obviously is less than 0. So this means that the volume V is maximum. Okay, so this stationary volume V that we have found is actually a maximum, and we are done with question number 9.